January 4, 1945. Over Huwei Airfield, Formosa. The Pratt & Whitney R2800 double Wasp engine driving Lieutenant Charles Valentine August's F-65 Hellcat suddenly began losing power at precisely the worst moment during a combat mission. 7,500 feet above enemy territory, escorting Avenger torpedo bombers on their strike run against Japanese installations, the massive radial engine that had carried him faithfully across thousands of miles of Pacific Ocean now coughed, sputtered, and began its terminal descent toward silence. August had no choice. The dive toward Huwei Airfield below came fast, the ground rushing up as he fought to control an aircraft rapidly transforming from predator to wounded bird. The wheels-up landing tore through the soft earth near the airfield, metal shrieking against dirt, but the Hellcat's legendary structural strength held. Bureau No. 7, 1441. Assigned to Fighting Squadron 44, aboard USS Langley, came to rest largely intact in territory controlled by the Imperial Japanese Navy. Within hours, Japanese recovery teams swarmed the crash site. They had captured American aircraft before, patchwork collections of damaged machines that rarely survived long enough to provide meaningful intelligence. But this Hellcat, aside from the engine failure that forced August down and the belly landing damage, remained remarkably complete. Every system, every component, every design feature that had made the F-6F series the most lethal carrier fighter in the Pacific remained available for examination by engineers, desperate to understand how American industry had produced an aircraft that was systematically destroying Japanese air power across the entire theater. The Hellcat bore tail number 29 and wore the markings of VF-44. Japanese personnel at Huwei photographed the aircraft meticulously, documenting every angle before transport. The fighter was initially displayed at a local shrine, a trophy representing Japanese defensive success. But Imperial Navy technical officers recognized immediately that this particular prize represented far more than propaganda value. Orders came swiftly from naval headquarters. Bureau No. 7, 1441, would be transported to Yokosuka Naval Base near Tokyo for comprehensive evaluation by the Navy's most experienced test pilots and engineers. The journey from Formosa to Japan transformed an enemy aircraft into an instrument of uncomfortable revelation. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. By early 1945, the Imperial Japanese Navy faced a crisis that transcended simple numerical disadvantage. American carrier task forces roamed the Pacific with seeming immunity, their air groups achieving kill ratios that would have seemed impossible to Japanese planners just 3 years earlier. The Mitsubishi A6M0, which had dominated the skies in 1941 and 1942 through superior maneuverability and range, now fell from the sky in appalling numbers whenever Hellcats appeared. Japanese pilots, even experienced veterans who had survived years of combat, reported with growing urgency that American fighters possessed capabilities that fundamentally altered the tactical calculus of air combat. Speed that allowed American pilots to dictate engagement terms, diving away from unfavorable encounters faster than Japanese fighters could pursue. Structural strength that absorbed battle damage, which would have destroyed Japanese aircraft outright. Most troubling of all, firepower that seemed capable of disintegrating Japanese aircraft with burst durations measured in seconds rather than sustained firing runs. Official reports circulating through Japanese naval aviation circles described American fighters in terms that grew progressively less optimistic as the war progressed. Early assessments from 1943 had acknowledged American numerical advantage while maintaining confidence in Japanese pilot skill and aircraft capabilities. By 1944, those assessments had shifted to discussing tactical countermeasures that might mitigate specific American advantages. By January 1945, when Bureau No. 7 1441 arrived at Yokosuka, Japanese aviation circles understood they faced opponents whose industrial and engineering capabilities had produced weapons systems. Japan could not match through any combination of tactics or pilot courage. Yokosuka Naval Base, located at the entrance to Tokyo Bay, approximately 65 kilometers south of Tokyo, served as one of the Imperial Japanese Navy's premier facilities throughout the war. The base included extensive shipbuilding facilities that had constructed battleships and aircraft carriers, a sophisticated naval air technical arsenal that designed and tested aircraft, comprehensive workshops equipped with precision tools, and test ranges specifically configured for detailed evaluation flights under controlled conditions. By January 1945, American bombing had not yet reached the intensity that would characterize the final months of the war, but Yokosuka personnel operated under constant awareness that Allied forces were advancing inexorably toward Japan itself. The facility remained operational, but resources had become increasingly scarce, spare parts increasingly difficult to obtain, and aviation fuel strictly rationed for only the most critical operations. Testing captured enemy aircraft fell into that critical category, representing one of the few remaining opportunities for Japanese engineers to understand precisely why they were losing the air war so catastrophically. The captured Hellcat underwent initial inspection by teams of specialists representing multiple technical branches of the Imperial Navy. Engineers photographed every component from dozens of angles, measured every dimension with precision instruments available to them, and documented construction techniques that seemed remarkably straightforward compared to Japanese manufacturing methods, requiring extensive hand-fitting and adjustment. The aircraft received Japanese markings, the distinctive red Hinomaru overpainted on American star insignias, though Japanese painters applied their work hastily and the American markings remained visible beneath. The tail received the designation code YO801, identifying it as property of the Yokosuka Kokutai, Yokosuka Naval Air Group. The initial visual inspection alone provoked substantial discussion among Japanese engineers who examined the airframe. The Hellcat measured 33 feet 7 inches in length with a wingspan of 42 feet 10 inches when the wings were extended for flight, folding to just 16 feet 2 inches for carrier storage, a critical consideration for the space-constrained environment aboard aircraft carriers. Empty weight was recorded at 9,154 pounds, with maximum takeoff weight reaching 15,413 pounds when fully loaded with fuel, ammunition, and external stores. These figures represented substantial mass compared to the Zero fighter, which weighed just over 4,000 pounds empty. The Hellcat carried more than twice the structural weight of Japan's primary fighter, yet Japanese engineers noted with growing unease that American accounts indicated the F-6F matched or exceeded the Zero in most critical performance categories, despite this massive weight penalty. The implications were sobering regarding the sophistication of American aerodynamic design and engine technology. The power plant attracted immediate intense scrutiny from Japanese propulsion specialists. The Pratt & Whitney R-2800 to 10 WWII radial engine represented American engineering at its most mature and refined level. An 18-cylinder, 2-row, air-cooled radial engine configuration, the R-2800 produced approximately 2,000 horsepower under military power settings, with water injection available for emergency power that briefly pushed output even higher. The engine displaced 2,800 cubic inches, hence its numerical designation, and employed a two-stage supercharger that maintained power output to altitudes exceeding 30,000 feet. Japanese engineers possessed sophisticated understanding of engine theory and design principles. The Zero's Nakajima Sakai engine demonstrated elegant engineering within severe resource constraints Japan faced. But examining the Double Wasp revealed design margins and manufacturing quality that Japan simply could not replicate under wartime conditions. The supercharger system alone incorporated complexity that Japanese industry struggled to produce consistently. American metallurgy provided materials capable of sustained high-temperature operation that Japanese substitute materials could not match. Manufacturing tolerances maintained across thousands of individual engines spoke to industrial capacity and quality control procedures fundamentally beyond Japanese capabilities. By 1945, The armament installation revealed the most dramatic disparity between Japanese and American design philosophies. 6 Browning M2, AN-M2 50 caliber heavy machine guns, arranged 3 per wing in the outer wing panel's outboard of the landing gear, with 400 rounds per gun. 2,400 total rounds of half-inch ammunition, each round weighing approximately 4 ounces, representing nearly 600 pounds of ammunition weight alone. The installation impressed and troubled Japanese engineers in equal measure. Japan's primary carrier fighters, the Zero and the Kawanishi N-1K George, typically mounted 2 20mm cannon plus 2 7.7mm machine guns, or similar mixed armament. The cannon provided excellent destructive power against individual targets but carried limited ammunition, perhaps 60 to 100 rounds per gun. Pilots learned to conserve ammunition carefully, firing only when confident of scoring hits. Burst durations were necessarily brief to avoid depleting ammunition supplies during extended combat. The Hellcat's 650 caliber installation represented an entirely different combat philosophy. Each M2 gun fired at approximately 750 to 850 rounds per minute when installed in aircraft, the higher rate of fire compared to ground variants achieved through lighter barrels and air cooling from the aircraft's slipstream. 6 guns firing simultaneously produced a combined theoretical rate exceeding 4,800 rounds per minute, though actual tactical bursts typically lasted 1 to 3 seconds. Even a 2-second burst from all 6 guns fired approximately 160 rounds total, nearly 16 pounds of projectiles hurled downrange with enough kinetic energy and incendiary content to shred any Japanese aircraft caught in the stream. The 400 rounds per gun provided sufficient ammunition for sustained combat, allowing Hellcat pilots to fire whenever they had reasonable probability of hitting targets without obsessively conserving ammunition for only perfect shot opportunities. Japanese test pilots who would later fly Bureau No. 71441 noted in their assessment reports that the psychological impact of this firepower concentration could not be overstated. American pilots could, and frequently did, open fire at longer ranges than Japanese pilots would consider practical, using the volume of fire to compensate for reduced probability of hitting at extended distances. The sheer density of the defensive box that 650 caliber guns created meant that any Japanese aircraft entering that beaten zone faced near-certain catastrophic damage. Contemporary Japanese pilot accounts and training lectures documented efforts to understand and counter the Hellcat's overwhelming advantages. One such lecture, delivered to Japanese Army pilots in 1945 by Lieutenant Yokota, who had studied captured American aircraft, survives in translated form. Lieutenant Yokota's assessment of the F-6F acknowledged forthrightly the disadvantages Japanese pilots faced. The Hellcat was not as maneuverable as lightweight single-engine Japanese fighters in sustained turning combat, particularly at lower altitudes and slower speeds where the Zero excelled. In hard dives from extremely high altitude, the Hellcat could experience vibration from air compression that potentially risked structural failure, though Japanese pilots noted this limitation rarely manifested in actual combat conditions, since Hellcat pilots typically avoided excessively prolonged vertical dives. Air combat at lower altitudes with slower speeds was less advantageous for the Hellcat compared to its dominating performance at medium and high altitudes. But Yokota's lecture also emphasized that these theoretical disadvantages provided little practical benefit to Japanese pilots in actual combat. The Hellcat's clear superiority in speed, dive performance, zoom climb capability, and especially its devastating firepower concentration, meant American pilots simply refused to fight in the limited circumstances where Japanese aircraft retained advantages. The teamwork tactics American pilots employed, flying in mutually supporting pairs or divisions, made breaking up their formations extremely difficult. Once Japanese pilots succeeded in isolating a single Hellcat for what should have been advantageous 1-versus-1 turning combat, that isolated Hellcat would typically extend away using its superior speed before the Japanese pilot could achieve killing position. The lecture concluded with advice that essentially acknowledged the hopeless tactical situation. Know the enemy aircraft performances thoroughly to avoid being surprised, maintain mental composure under stress, and recognize that fighting with guts alone without understanding the performance disparities guaranteed death. Bureau Number 7, 1441, received repairs to address the engine failure that had forced Lieutenant August's emergency landing and the damage sustained during the wheels-up crash. Japanese technicians, working with limited spare parts and no access to genuine Pratt & Whitney components or factory technical manuals, demonstrated considerable ingenuity in returning the Hellcat to airworthy condition. Components were fabricated to replace damaged parts where possible, systems were tested and adjusted until functionality was restored, and the massive radial engine received particular attention from specialists who understood this power plant represented the heart of the aircraft's formidable performance. The repair process took several weeks, but by late January or early February 1945, the Hellcat bore the marking Yo 801 and sat ready for its first test flight under Japanese control at Yokosuka. An experienced Imperial Navy test pilot climbed into the cockpit for the initial evaluation flight, about to experience firsthand what thousands of Japanese combat pilots had encountered with fatal results across the Pacific, what American engineering and industrial capacity could produce when applied to military aviation. The cockpit layout immediately impressed the Japanese test pilot familiar with the cramped confines of Zero fighters and even the more spacious accommodations of newer Japanese designs. The Hellcat cockpit demonstrated thoughtful ergonomic design, with controls logically arranged and positioned within easy reach, reducing pilot workload during the intense mental demands of combat flying. Instruments were clearly marked with easily readable gauges and sensibly grouped by function, following human factors principles that prioritized pilot effectiveness over theoretical optimization. The seat provided noticeably better comfort than Japanese fighters, an important consideration during multi-hour missions where pilot fatigue could significantly impact performance and decision-making. Visibility from the cockpit, though not as exceptional as the later bubble canopy P-51 Mustang, still exceeded what Japanese pilots experienced with their heavily framed canopies and restricted sightlines. The Hellcat pilot could see reasonably well in all directions, with particular advantage in forward and lateral visibility critical for spotting enemy aircraft and maintaining formation position. But the true revelation came when the Japanese test pilot advanced the throttle and felt the Pratt & Whitney R2800 Double Wasp respond with smooth, progressive power delivery. The massive radial engine built steadily and predictably as the Hellcat accelerated down Yokosuka's runway, the three-bladed Hamilton Standard propeller biting efficiently into the air with authority that spoke to immense power reserves. The takeoff roll was noticeably shorter than expected for an aircraft of the F-6F's weight and size, clear testimony to the engine's substantial power output and the airframe's efficient aerodynamic design that minimized drag throughout the speed range. Once airborne, the Hellcat demonstrated handling characteristics that fundamentally challenged everything Japanese pilots thought they understood about American aircraft design philosophy and engineering capabilities. The flight controls were beautifully harmonized, with aileron, elevator, and rudder forces perfectly balanced across the entire speed range, from approach speeds to maximum velocity. Control forces increased predictably with speed, providing good tactile feedback to the pilot, without becoming excessively heavy, and decreased smoothly at lower speeds without becoming overly sensitive or twitchy in ways that could surprise pilots during critical phases of flight. The Hellcat responded crisply and predictably to control inputs without displaying the oversensitivity or nervous handling characteristics that plagued some fighters. Roll rate exceeded that of most Japanese fighters significantly, allowing rapid changes in flight direction that were critical for both offensive maneuvering to achieve firing position and defensive maneuvering to evade enemy attacks. The aircraft could be thrown aggressively into various maneuvers without displaying any troubling tendency toward departure from controlled flight, spin entry, or other dangerous characteristics that could prove fatal in combat situations where pilots routinely operated at the edges of their aircraft's performance envelope. Japanese test pilots systematically evaluated the Hellcat's performance through carefully planned test flights, pushing the aircraft through standardized maneuvers specifically designed to reveal its strengths, limitations, and any hidden dangerous characteristics that might be exploitable in combat. Climb performance impressed them considerably and generated significant concern about tactical implications for Japanese defensive operations. The F-65 could maintain excellent climb rates to altitudes exceeding 30,000 feet, where the two-stage supercharged double WASP engine continued, producing substantial power even as the progressively thinner air at altitude severely degraded performance in Japanese fighters equipped with single-staged superchargers or less sophisticated boost systems. High-altitude performance particularly concerned Japanese pilots and tactical planners because American bomber formations typically operated between 20,000 and 30,000 feet, where the air was thin and cold but defensive fire from bomber gunners remained highly effective against fighters that had to slow down significantly to attack effectively. Japanese interceptors struggled increasingly at these altitudes, their engines gasping for sufficient air while power output dropped dramatically, while the Hellcat's sophisticated two-stage supercharger with intercooler continued delivering robust, reliable power that translated into maintained speed advantage and maneuverability. The revelation proved sobering to pilots and commanders who understood the tactical implications. The Hellcat could not only escort bombers to these altitudes, but could fight there effectively, maintaining speed advantage and crisp maneuverability, while Japanese interceptors labored with reduced power, slower speeds, and degraded handling as their engines fought against the thin atmosphere. Any air combat at altitudes above 25,000 feet heavily favored American fighters equipped with sophisticated supercharger systems, eliminating altitude as a viable sanctuary for Japanese defenders. Speed trials conducted under controlled conditions at various altitudes confirmed the Hellcat's clear superiority in this critical performance category. The F-65 could achieve approximately 380 miles per hour at optimal altitude with the engine running at military power settings, significantly faster than the Mitsubishi A6M0's, approximately 350 miles per hour maximum speed, and the Kawanishi N1K George's approximately 369 miles per hour when measured, under comparable conditions. This substantial speed advantage proved tactically decisive in combat because it fundamentally allowed Hellcat pilots to dictate engagement terms according to their advantage. American pilots could choose when to engage, pursuing fleeing Japanese fighters when the tactical situation favored attack, and closing rates exceeded the escape velocity Japanese aircraft could achieve. Equally important, American pilots could choose to disengage from unfavorable encounters, accelerating away from Japanese fighters that lacked sufficient speed to pursue effectively, or force continued combat against American pilots' wishes. Japanese test pilots discovered through mock combat exercises that they could not force combat on a Hellcat whose pilot recognized an unfavorable situation and chose to avoid engagement, fundamentally undermining Japanese tactical flexibility and reducing combat effectiveness to whatever fleeting opportunities American pilots chose to provide. The speed differential eliminated the Japanese ability to control combat geometry, transforming air combat from a contest between equally matched opponents into a predator-prey relationship where the predator possessed overwhelming advantages. The wing design of the F-6F, based on NACA laminar flow airfoil sections researched extensively in American wind tunnels before the war, gave the Hellcat its distinctive appearance and delivered exceptional aerodynamic efficiency throughout the flight envelope. Japanese engineers noted that achieving true laminar flow in operational conditions remained elusive due to manufacturing tolerances, surface imperfections, rivets, paint application, and operational wear that disrupted the smooth airflow theoretical laminar wings required. Nonetheless, the F-6F's wing generated substantial lift with minimal drag compared to conventional airfoils Japanese designers employed, significantly contributing to the aircraft's remarkable range capability and fuel efficiency that allowed extended combat air patrol missions impossible for Japanese fighters. This wing design maintained its effectiveness across a remarkably broad speed range, from relatively low-speed handling during landing approaches through high-speed performance during combat maneuvering providing consistent, predictable handling characteristics that reduced pilot workload and enhanced combat effectiveness across all phases of flight. Dive performance revealed yet another area where the Hellcat demonstrated clear superiority over Japanese fighters. The aircraft could dive at very high speeds without encountering the severe control, stiffening, control reversal, or reduced control effectiveness that plagued many fighters when approaching or exceeding their maximum design speeds. Japanese pilots could pull out of steep high-speed dives without requiring excessive physical effort or fighting against locked controls that refused to respond to pilot inputs, and the airframe remained stable throughout the maneuver without tendency toward flutter, buffeting, or structural failure that could result in catastrophic breakup. Japanese test pilots noted this capability with particular interest and concern because diving attacks represented a primary tactical doctrine for engaging bomber formations and their escorts, attacking from altitude advantage to build speed and energy before pulling back up to regain altitude. The Hellcat's ability to follow Japanese fighters through high-speed dives while maintaining full control authority throughout the maneuver eliminated a key tactical advantage Japanese pilots had enjoyed against earlier American fighters like the F-4F Wildcat, which suffered from poor dive performance and heavy controls at high speeds. Turn performance presented a more complex and nuanced picture that required careful analysis by Japanese test pilots seeking any exploitable weakness. The Hellcat could not match the sustained turn rate of the Zero in level flight at moderate speeds, particularly as the Zero benefited from leading-edge slots that automatically deployed during high angle of attack maneuvering and delayed wing stall during tight sustained turns. In slow-speed turning fights at medium altitudes, the lighter and more aerodynamically optimized Zero held a measurable advantage in turn radius and turn rate that could theoretically allow a skilled Japanese pilot to achieve firing position against a Hellcat that accepted sustained turning combat. However, Japanese pilots discovered through systematic testing and mock combat that the Hellcat's clear superiority in speed, climb rate, and energy retention allowed skilled pilots to avoid sustained turning engagements entirely, and instead fight using energy tactics that maximized American advantages while minimizing Japanese strengths. The Hellcat excelled at converting speed to altitude and altitude back to speed efficiently, a characteristic called energy maneuverability that enabled pilots to maintain energy state throughout combat maneuvering. This capability allowed Hellcat pilots to engage when advantageous and disengage when threatened, forcing combat on their terms rather than accepting the enemy's preferred combat geometry. Japanese pilots might achieve fleeting advantage during brief turning exchanges, but Hellcat pilots would simply extend away using superior speed, climb back to altitude advantage, and reverse back into the engagement with renewed energy advantage when conditions again favored attack. The turning advantage Japanese fighters possessed existed only if American pilots made the tactical error of accepting sustained turning combat, an error well-trained Hellcat pilots rarely committed. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Hellcat's structural strength and robust construction impressed Japanese engineers who examined the airframe in systematic detail at Yokosuka. The aircraft was substantially built with significant safety margins engineered into critical structural components throughout the airframe, reflecting American design philosophy that prioritized survivability and operational longevity over absolute weight minimization. This robust construction philosophy contrasted markedly with Japanese design approaches that often pushed structural limits to absolute minimums in pursuit of weight reduction and maximum performance specifications. The F-6F could sustain significant battle damage that would have destroyed lighter Japanese aircraft and still successfully return to base, a capability that directly translated into pilot survival rates and aircraft availability for subsequent missions. Japanese pilots frequently reported encountering Hellcats during combat that absorbed hits from 20mm cannon fire that should have been fatal, yet continued fighting effectively or escaped the combat area to return safely to their carriers. The structural margins built into American fighters meant that non-critical hits rarely resulted in aircraft loss, While similar damage to Japanese aircraft often proved catastrophic, American engineering philosophy clearly emphasized survivability and maintainability, accepting somewhat higher empty weight in exchange for durability that kept aircraft and pilots in combat operations longer. The Hellcat featured armor protection around the cockpit, totaling 212 pounds, including a bullet-resistant windscreen that could stop small arms fire and shell fragments. Self-sealing fuel tanks prevented fires from tracer rounds or incendiary ammunition that routinely ignited Japanese aircraft lacking such protection. The oil cooler received armor protection. Critical components throughout the aircraft featured redundant systems or backup capabilities that allowed continued operation even after battle damage disabled primary systems. Japanese fighters, designed under severe weight restrictions and resource limitations, typically featured minimal armor protection and lacked self-sealing fuel tanks that required synthetic rubber Japan could not produce in sufficient quantities. The weight penalty for armor and self-sealing tanks seemed prohibitive to Japanese designers working within strict weight budgets, but combat experience demonstrated conclusively that survivability features translated directly into operational advantage through higher pilot survival rates and aircraft recovery percentages. Range capabilities astounded Japanese pilots accustomed to the Zero's exceptional range, which had seemed remarkable earlier in the war, but which the Hellcat exceeded through superior fuel efficiency and larger fuel capacity. The F-65 carried approximately 250 gallons of fuel internally in self-sealing tanks located in the fuselage, substantially more internal fuel than most fighters carried. The aerodynamically efficient wing design translated this fuel capacity into truly extraordinary range that seemed almost incredible to Japanese pilots, who understood fuel consumption rates and typical combat radius limitations. With external drop tanks attached under the fuselage centerline and underwing hardpoints, the Hellcat could fly missions exceeding 6 hours duration, covering operational distances that enabled strategic escort missions across vast expanses of Pacific Ocean. Internal fuel alone provided combat radius exceeding 600 miles under typical combat conditions, while external tanks extended range to nearly 1,500 miles total, enabling escort missions to targets deep in Japanese-held territory and safe return to carrier task forces operating hundreds of miles offshore. This massive range advantage fundamentally transformed bomber escort operations in ways that proved strategically decisive for American naval aviation. Early in the Pacific War, Japanese fighters could simply wait until shorter-range American escorts reached their fuel limits and turned back toward their carriers, then attack unprotected bombers during the most dangerous portions of their missions, approaching and departing heavily defended targets. The Hellcat completely eliminated this tactical window that had caused such heavy bomber losses earlier in the war. American escorts could now accompany bombers and torpedo planes throughout entire strike missions against targets at any distance from the carrier task force, preventing Japanese fighters from ever finding truly vulnerable targets lacking fighter protection. The strategic implications were profound and deeply troubling to Japanese commanders, who understood that their fighters now had to fight through escorts to reach bombers, dramatically increasing the risk Japanese pilots faced on every interception, sortie, and reducing the effectiveness of defensive operations that had once relied on eliminating escorts through fuel exhaustion. The maintenance accessibility surprised Japanese ground crews familiar with the sometimes extraordinarily difficult servicing requirements of Japanese fighters, particularly when working under field conditions with limited equipment on remote island airfields or aboard carriers with confined working spaces. The Hellcat's engine cowling opened in multiple sections that provided excellent access to the double Wasp engine and its accessories, fuel system components, hydraulic components, and electrical systems that required regular inspection and adjustment. Panels throughout the airframe could be quickly removed using standard tools to reach internal systems for inspection, adjustment, or component replacement without requiring extensive disassembly of surrounding structures. The overall design clearly reflected American emphasis on rapid maintenance, turnaround, and high operational availability, recognizing that aircraft sitting on the ground awaiting repairs contributed nothing to combat effectiveness, regardless of their theoretical performance capabilities when actually flying. Japanese aircraft, while often featuring elegant engineering solutions and impressive performance specifications, frequently required extensive maintenance procedures that consumed hours of skilled technician time for routine servicing. Access panels were sometimes poorly located, requiring removal of multiple components to reach systems needing adjustment. Tolerances were tight, requiring precision hand-fitting during assembly and reassembly. The emphasis on weight reduction sometimes resulted in fragile components that required careful handling and frequent replacement. The Hellcat's maintenance-friendly design philosophy reflected decades of American civilian aviation experience, where reliability and ease of service directly impacted commercial profitability. Military aircraft inherited these design principles, resulting in fighters that could sustain high operational tempo, with relatively modest maintenance support, compared to Japanese aircraft requiring extensive servicing between missions. Bureau No. 7, 1441 flew numerous test flights throughout February and March 1945, as Japanese pilots and engineers accumulated detailed performance data under various conditions. Each flight revealed additional confirmation of what Japanese combat pilots had been reporting, with increasing urgency throughout 1944. American fighters possessed decisive advantages that no amount of pilot skill or tactical cleverness could overcome through sustained operations. At some point during the testing program, likely in March or April 1945, Bureau No. 71441 suffered another mechanical problem during flight operations. The precise nature of the failure remains unknown from surviving records. But the aircraft executed another belly landing at Yokosuka, this time incurring more substantial damage than the original crash landing on Formosa. Japanese technicians, already struggling with severe shortages of spare parts and materials, lacked the resources to repair the Hellcat again. The aircraft was pushed aside into a grass dispersal area away from active flight operations, abandoned as repair priorities shifted to Japanese aircraft that could actually influence combat outcomes. There, Bureau No. 71441 sat through the final months of the Pacific War, slowly deteriorating as paint faded, panels loosened, and weather took its toll on an aircraft that had traveled from American factory to combat operations aboard USS Langley, to forced landing on Formosa, to Japanese evaluation at Yokosuka, to final abandonment as the empire crumbled around it. The strategic situation Japan faced by spring 1945 had deteriorated beyond any possibility of reversal through conventional military operations. American carrier task forces operated with seeming immunity around the Japanese home islands, launching devastating strikes against remaining naval units, industrial facilities, and airfields with overwhelming superiority in aircraft numbers and pilot quality. The Philippines had fallen, Iwo Jima had fallen. Okinawa would fall in June after brutal fighting that consumed the last effective Japanese air units in futile kamikaze attacks that achieved tactical damage but changed nothing strategically. The captured Hellcat testing program at Yokosuka represented a sophisticated and professional attempt to understand enemy capabilities through systematic analysis, but understanding a problem and solving it proved fundamentally different challenges. Japanese engineers and test pilots who flew Bureau No. 71441 wrote detailed reports documenting their findings, circulating technical intelligence through appropriate channels to inform tactical planning and aircraft development programs. The reports confirmed what combat experience had already demonstrated. The F-6F represented mature American engineering applied to naval aviation, with results Japan could not match given resource constraints and industrial capabilities. Several factors contributed to the Hellcat's overwhelming success that Japanese analysis identified but could not replicate. American automotive industry experience provided decades of practical knowledge about mass production, reliability engineering, and designing for maintainability that Japan's less developed consumer economy had never generated. Access to strategic materials, particularly high-grade aluminum alloys, advanced steels, and synthetic rubber for self-sealing fuel tanks, allowed American designers to create structures combining strength with acceptable weight while maintaining production efficiency. Manufacturing quality control across tens of thousands of aircraft maintained remarkably tight tolerances and consistent build quality that Japanese industry, increasingly reliant on dispersed production facilities and inadequately trained labor, could no longer achieve under wartime conditions. The pilot training pipeline, providing American naval aviators with 300 to 400 hours of flight training before reaching operational squadrons, produced pilots capable of extracting maximum performance from their aircraft, while Japanese training programs, shortened by fuel shortages and facility losses, produced inadequately prepared pilots with barely 100 hours total flight time. Most fundamentally, the Hellcat represented an intelligent design compromise that prioritized characteristics most valuable for its intended strategic mission of carrier-based fighter operations in the vast Pacific theater. Speed, range, high-altitude performance, structural strength, ease of maintenance, and overwhelming firepower all received design emphasis, even at the cost of ultimate maneuverability that Japanese fighters pursued as their primary performance goal. American designers understood that sustained turning combat represented poor tactical choice when superior speed and energy management could achieve the same combat objectives with lower risk. Japanese fighter development programs initiated during 1944 attempted to counter American advantages through advanced designs incorporating lessons learned from combat experience and captured aircraft analysis. The Kawanishi N-1K George represented Japan's best effort at matching Hellcat capabilities, featuring improved speed, better high-altitude performance through more sophisticated supercharger systems, heavier armament, and stronger airframe construction. But George arrived too late and in too small numbers to influence strategic outcomes. Production difficulties, material shortages, and disruption from American bombing prevented mass production of advanced designs that might have been more competitive against American fighters. By the time improved Japanese fighters reached operational units in meaningful numbers, pilot quality had degraded so severely through catastrophic attrition and shortened training that even superior aircraft could not overcome the accumulated disadvantages Japan faced. The final months of World War II in the Pacific witnessed systematic destruction of Japanese air power through overwhelming American numerical superiority, superior aircraft performance, better trained pilots, and devastating close air support that accompanied every amphibious landing. Japanese fighters that managed to reach American formations faced such density of defensive fire from multiple Hellcat divisions, flying mutual support tactics, that achieving successful attacks required either exceptional skill and luck or willingness to execute suicidal single-pass attacks that might damage one target before the attacker was destroyed. The kamikaze campaign represented final admission that conventional air combat operations could not achieve meaningful results against American carrier forces protected by Hellcat combat air patrols, maintaining stations throughout daylight hours, and F-6, 5N, night fighter variants, equipped with radar for nocturnal operations. If Japanese pilots could not survive long enough in conventional combat to inflict damage, then suicide attacks, eliminating pilot survival from the tactical equation, at least guaranteed achieving one attack run before inevitable destruction. American forces occupied Yokosuka Naval Base on August 30, 1945, shortly after Japan's formal surrender ended hostilities. Marines and sailors moving through the facility discovered numerous Japanese aircraft in various states of disrepair, some hidden in dispersal areas, some abandoned on runways, some pushed into maintenance hangars. Among the captured Japanese aircraft sat one unexpected discovery, a Grumman F-65 Hellcat bearing Japanese markings and the tail code Yo-801, badly weathered and showing damage from its second belly landing months earlier. American personnel photographed Bureau No. 7, 1441 extensively, documenting both sides of the aircraft in images that have survived to provide valuable reference for historians and modelers interested in this unique machine's unusual second career. The photographs show the crudely applied Japanese Hinomaru markings overpainted on American insignias, with Japanese paint showing wear and deterioration. The tail code Yo801 was applied with obvious paint drips visible in photographs. The original Bureau number 71441 remained clearly visible on the tail beneath Japanese markings. The aircraft had deteriorated substantially since abandonment months earlier. Additional damage evident in photographs likely resulted from being moved by American occupation forces who consolidated captured Japanese equipment. Weather exposure had taken a further toll on an airframe no longer receiving maintenance attention. The landing gear remained retracted from the belly landing, panels showed loosening. The overall condition spoke to an aircraft that had reached the end of its operational life through a combination of combat damage, testing accidents, lack of spare parts, and simple abandonment as more pressing priorities consumed Japanese attention during the Empire's final collapse. Bureau number 71441 was likely destroyed at Yokosuka, along with many captured Japanese aircraft that American forces scrapped during the occupation. No records indicate the Hellcat received repair and returned to American service. The aircraft had fulfilled its unintended mission of providing Japanese pilots and engineers direct experience with American fighter capabilities, revealing truths that combat reports had suggested, but which direct hands-on evaluation confirmed beyond any doubt. The story of Lieutenant Charles Valentine August continued beyond his forced landing and capture. The pilot survived imprisonment in a POW camp near Tokyo under conditions that tested human endurance during the final desperate months of the Pacific War, when Japanese supply systems collapsed and guards themselves faced starvation. August endured captivity until Japan's surrender freed Allied prisoners throughout the home islands. He returned home with 3 aerial victories to his credit, including 2 Vichy French aircraft shot down over North Africa during Operation Torch in November 1942 and 1 Japanese Zero in the Pacific. Remarkably, August held the distinction of being possibly the only United States naval aviator who was captured twice during World War II. His first capture by Vichy French forces in North Africa ended with repatriation after the ceasefire, when French forces switched allegiance to the Allies. His second capture by Japanese forces in January 1945 led to months of brutal captivity until war's end. His survival through both ordeals and return to service between captures testified to resilience and determination characteristic of the naval aviators who flew Hellcats across the Pacific. The Grumman F-6F Hellcat series compiled one of the most impressive combat records of any fighter aircraft in World War II, through combination of superb design, excellent manufacturing quality, superior pilot training, and numerical advantage that overwhelmed opponents. Hellcats were credited with destroying 5,156 enemy aircraft during the war, while losing only 270 F-6Fs in air-to-air combat, producing a kill-to-loss ratio of 19:1 that remains among the highest achieved by any fighter aircraft in history. 306 American naval aviators became aces while flying Hellcats, achieving 5 or more aerial victories in the type. Lieutenant Commander David McCampbell, the United States Navy's top ace of World War II, scored all 34 of his victories flying Hellcats, including an extraordinary engagement on October 24, 1944, during the Battle of Leyte Gulf, when he shot down 9 Japanese aircraft in a single mission. Such performances demonstrated not just aircraft capability, but the synergy between excellent machine and well-trained pilot working together at peak effectiveness. Perhaps most remarkably, American carrier-based bombers and torpedo planes lost only 42 aircraft to Japanese fighters during the entire period from 1943 through 1945, when Hellcats provided escort. This statistic, more than any other, demonstrated the F-6F's effectiveness in its primary mission of protecting strike aircraft. Japanese interceptors that had once taken heavy tolls on unescorted or inadequately escorted American bombers now faced such effective Hellcat screens that reaching bombers became nearly impossible without first fighting through defenders, who held every tactical advantage. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.